From the earliest days of humanity, we have gazed up at the stars and wondered about our place in the cosmos. This curiosity, this deep-seated desire to explore the unknown, is woven into the very fabric of our being. It is what drove us to leave the comfort of our caves and venture out into uncharted territories. What began with mapping the Earth has evolved into a relentless pursuit to understand the vast universe that surrounds us. This quest for knowledge and our innate drive to push the boundaries of what's possible are what fuel our dreams of one day living among the stars. The dream of living on other planets, once relegated to the realm of science fiction, is now within the grasp of scientific inquiry. While significant challenges remain, the seeds of possibility have been sown. We are no longer merely asking if we can live on other planets, but when and how. Scientists and engineers are actively working on solutions to the myriad hurdles that stand between us and a multiplanetary future. One of the most significant challenges is the sheer distance involved in space travel. Even the closest star system to our own, Alpha Centauri, is over 4 light years away. This means that even traveling at the speed of light, a journey to another star system would take years. While current technology limits us to speeds far slower than light, advancements in propulsion systems such as ion propulsion and nuclear fusion offer a glimmer of hope for faster travel in the future. The challenges of space colonization necessitate innovations that seem ripped from the pages of science fiction. Creating a self-sustaining habitat on another planet requires groundbreaking solutions. 3-dimensional printing technology offers a promising avenue for constructing habitats. Imagine robots autonomously assembling structures, creating entire settlements. These habitats would provide crucial protection from radiation and meteorite impacts. We need to create entirely self-sufficient ecosystems within these habitats. Nuclear power could provide a reliable and sustainable energy source for these extraterrestrial outposts. Life on Earth depends on a delicate balance of interconnected ecosystems. Replicating such complexity in the harsh and sterile environment of another planet is a monumental undertaking. Food production, a cornerstone of any self-sustaining colony, requires innovative approaches. Traditional agriculture, reliant on fertile soil, ample sunlight and fresh water, is impractical in space. Enter the concept of vertical farming. Imagine towering structures bathed in the glow of artificial sunlight, where layers upon layers of crops grow in a nutrient-rich hydroponic solution. This method, already gaining traction on Earth, utilizes significantly less water and land compared to traditional farming, making it ideal for space. Complementing these vertical farms would be bioregenerative life support systems. These systems utilize the natural processes of plants and algae to convert carbon dioxide into oxygen, mimicking Earth's own carbon cycle. Furthermore, these systems could also recycle organic waste such as food scraps back into fertilizer, creating a closed-loop system for nutrient management. Beyond sustenance, a thriving colony needs diversity. Genetically engineered crops tailored to thrive in specific extraterrestrial environments could provide a wider range of food options and essential nutrients. Imagine Martian greenhouses bathed in the reddish hue of the Martian sky, cultivating specially adapted fruits and vegetables, enriching the diets of future Martian colonists. This shift towards a closed-loop bioregenerative system represents a paradigm shift in how we think about resource management, a shift essential not only for space exploration but also for ensuring a sustainable future for humanity on Earth. The technologies and practices developed for space colonization could revolutionize food production and resource management on our own planet, paving the way for a more sustainable and equitable future. The vast distances between stars represent perhaps the most daunting hurdle for interstellar travel. Even at the speed of light, a journey to Proxima Centauri, the closest star to our Sun, would take over 4 years. Traditional chemical rockets, while powerful, are woefully inadequate for such journeys. New propulsion systems, harnessing the power of physics beyond our current understanding, are needed to breach the barriers of interstellar space. One such concept is nuclear fusion propulsion. This technology, still in its infancy, aims to replicate the processes that power the stars themselves. By fusing light atoms like hydrogen into helium, immense amounts of energy can be released, potentially propelling spacecraft to a significant fraction of the speed of light. Another intriguing possibility lies in harnessing the theoretical power of warp drives. These hypothetical devices, often relegated to the realm of science fiction, would manipulate the fabric of space-time itself, creating a bubble around the spacecraft that allows it to travel faster than the speed of light without violating the laws of physics. While still purely theoretical, the concept of warp drive continues to captivate scientists and fuel our dreams of interstellar travel. Even if we manage to achieve such incredible speeds, the journey itself poses significant challenges. Space is not an empty void, but a harsh and unforgiving environment. Cosmic radiation, micrometeoroids, and the extreme temperatures of interstellar space pose constant threats to any spacecraft. Developing advanced shielding technologies, robust spacecraft designs, and perhaps even artificial gravity systems to mitigate the effects of prolonged space travel will be crucial for ensuring the safety and well-being of interstellar voyages. Venturing beyond the protective embrace of Earth's magnetic field and atmosphere exposes us to a barrage of cosmic hazards. High-energy cosmic rays originating from distant supernovae and active galactic nuclei pose a significant threat to the health of space travelers. Prolonged exposure can damage DNA, increasing the risk of cancer and other health problems. Shielding against this invisible enemy requires innovative solutions. Traditional materials like lead are effective but far too heavy to launch into space in large quantities. Lightweight composite materials incorporating elements with high atomic numbers, like hydrogen-rich plastics or even water, offer a more practical solution. The design of the spacecraft itself can also play a role in radiation protection. Orienting living quarters towards the center of the spacecraft, surrounded by water tanks or other shielding materials, can create a protective barrier against cosmic rays. Additionally, incorporating artificial magnetic fields around spacecraft mimicking Earth's own protective magnetosphere is another concept under exploration. The lack of gravity in space, while liberating, poses its own set of challenges. The human body, adapted to Earth's gravity, suffers detrimental effects in its absence. Muscles atrophy, bones weaken, and cardiovascular systems are strained. Countermeasures for these effects are crucial for long-duration spaceflight and permanent settlements on other planets. Regular exercise routines, utilizing resistance bands and specialized exercise equipment, can help maintain muscle mass and bone density. Artificial gravity systems, though technologically challenging, offer a more comprehensive solution. Rotating habitats, generating centrifugal force to mimic gravity, or developing artificial gravity generators, though still in the realm of science fiction, could provide a more natural environment for humans living in space. The human body, a marvel of evolution, faces unprecedented challenges in space. Our survival depends on atmospheric pressure, gravity, and radiation shielding. In space, these protections vanish, causing severe physiological challenges. Lack of pressure leads to tissue swelling and potential death. Gravity's absence weakens bones, muscles, and the cardiovascular system. Radiation exposure increases cancer risk. Effective countermeasures are essential for long-term space missions. While the physical challenges of space travel are readily apparent, the psychological toll is often overlooked. Isolation and confinement can profoundly affect mental health. Loneliness, anxiety, and depression are common. Maintaining connection with Earth is crucial. Effective stress management techniques are essential. As we venture further into space, psychological challenges will become more pronounced. Creating supportive environments is essential for future exploration. Sustaining human life on other planets requires more than just addressing physiological needs. we must also consider social, cultural, and spiritual aspects in a spacefaring civilization. Creating a meaningful existence beyond Earth necessitates a holistic approach. How will these settlements be governed, and how will social structures evolve? Will artists and writers find new inspiration in alien worlds? Addressing these questions will be crucial for fostering a sense of purpose. As we stand on the precipice of becoming a multiplanetary species, we must confront the ethical implications of expanding our footprint into the cosmos. The decisions we make today will shape the future of humanity and our relationship with the universe. We must ensure our quest for knowledge is guided by ethical principles that prioritize the well-being of all life. Introducing Earth-based life to other planets could have unforeseen consequences. Strict planetary protection protocols are essential for safeguarding celestial environments. The allocation of resources and the distribution of benefits from space exploration raise complex ethical questions. Will access to space be limited to a privileged few, or will we strive for an inclusive future? How will we ensure that resources from other planets are used responsibly and sustainably? The potential for conflict and competition in space is another ethical concern. We must establish clear international agreements to govern activities in space and ensure peaceful cooperation. By embracing ethical principles, we can ensure our journey to the stars is one of progress and shared prosperity. The vast expanse of our solar system has become the new frontier for human ambition. While Earth remains our cradle, the search for a second home has begun. The challenges are immense, yet the drive to explore compels us to venture forth. Our solar system offers a surprising diversity of environments. Some hold the potential for harboring life, perhaps even becoming future homes. These celestial bodies are now being scrutinized as potential candidates for human settlements. Mars, the red planet, has long captured our imaginations as a potential second home. Its dusty plains hint at a watery past. The discovery of subsurface ice and organic molecules fuels our fascination with Mars. Beyond Mars, the gas giants possess moons that hold intriguing possibilities. Europa and Titan have captivated scientists as potential havens for life. These moons are now recognized as potential cradles for life. Mars, our rusty red neighbor, has captivated human imagination for centuries. Its blood-red hue sparked tales of war and conquest, but also ignited a fascination that has only deepened with scientific exploration. Mars, a cold, arid desert world, is a compelling target for human colonization. Unlike gas giants, Mars offers a somewhat familiar terrain. Its day-night cycle and gravity are similar to Earth's, and its surface holds promise. Water ice, trapped beneath the surface, represents a crucial resource. The challenges of transforming Mars into a habitable world are immense. Terraforming, making Mars more Earth-like, is moving from fiction to possibility. Melting polar ice caps could thicken the atmosphere, warming the planet. The journey to Mars presents significant hurdles. Cosmic radiation, confinement and isolation are challenges requiring innovation and resilience. Establishing a permanent human presence on Mars is a challenge we seem destined to embrace. While Mars might be the most obvious target for human colonization, the moons of our solar system offer alternative destinations, each with unique allure and challenges. Europa, Jupiter's icy moon, has a subsurface ocean potentially heated by Jupiter's gravity, creating a potential haven for life. Titan, Saturn's largest moon, has a dense atmosphere and lakes of liquid methane. These moons, once cosmic curiosities, are now seen as potential cradles for life. Beyond the familiar planets and moons of our solar system lies the asteroid belt, a vast ring of rocky remnants from the early solar system orbiting the Sun between Mars and Jupiter. While often depicted as a chaotic jumble of space rocks, a hazard to spacecraft. The asteroid belt also holds immense promise, both as a source of resources and as a potential platform for future human expansion into the cosmos. The asteroids themselves, remnants from the formation of our solar system, are rich in valuable resources, including water, precious metals, and even platinum group metals, which are rare on Earth but essential for advanced technologies. Mining these asteroids, extracting their resources, could provide a sustainable source of materials for future space exploration and development, reducing our reliance on Earth's finite resources. Beyond their resource potential, asteroids also offer a unique platform for constructing space habitat. These habitats, carved out of the asteroid's interior or assembled from multiple asteroids, could provide protection from radiation and micrometeoroids, while the asteroid's own rotation could be harnessed to create artificial gravity, mimicking the conditions on Earth. These asteroid habitats, strategically positioned throughout the solar system, could serve as stepping stones for human exploration, providing refueling stations, research outposts, and even permanent settlements for a spacefaring civilization. The development of asteroid mining and the construction of space habitats present formidable technological challenges, requiring advancements in robotics, space transportation, and resource extraction. Yet the potential rewards, both in terms of material resources and the expansion of human presence in the cosmos, make the asteroid belt a compelling target for future exploration and development. The search for a second home for humanity is a profound expression of our desire to explore and ensure our survival. The challenges are immense, but the rewards are immeasurable. As we venture beyond Earth, we carry our technology, dreams, and lessons from history. Space colonization mirrors challenges on Earth, fostering cooperation and sustainability. Discovering extraterrestrial life would transform our understanding of the universe. The journey to the stars is a quest to understand our place within the universe. It promises wonder, discovery, and a future where humanity thrives among the stars. The prospect of humans living on other planets presents a unique opportunity for introspection. As we contemplate establishing a presence beyond Earth, we are forced to confront fundamental questions about our values, our priorities, and what it truly means to be human. The challenges of space colonization serve as a magnifying glass, amplifying both the best and worst aspects of our nature, urging us to consider what kind of future we want to create among the stars. One of the most pressing questions we face is who gets to go to these new worlds? Will it be a select few, chosen for their skills and resilience, or will we strive for a more inclusive approach, ensuring that the opportunity to experience life beyond Earth is accessible to people from all walks of life? The history of colonization on Earth is rife with examples of exploitation and injustice, reminding us of the importance of creating a more equitable and just system as we venture into space. The establishment of settlements on other planets also raises questions about governance and social structures. Will these new societies replicate the political systems and social hierarchies of Earth? Or will they offer an opportunity to create something truly different? Will we perpetuate the inequalities and divisions that plague our world, or will we seize the chance to build societies based on cooperation, sustainability, and a shared commitment to the common good? The choices we make, both individually and collectively, will determine whether we create a future of peace and prosperity or repeat the mistakes of our past. Section 2. The Seeds of Discord. Human exploration is often marred by conflict, driven by competition for resources and territorial disputes. As we venture beyond Earth, the potential for discord remains. Vast distances and scarce resources could exacerbate tensions in space. Discovering valuable resources could spark new competition. The absence of legal frameworks could lead to disputes and military confrontations. Permanent settlements could lead to territorial disputes. As colonies grow, their interests might collide. Communication challenges could complicate disputes. Ideological differences could ignite conflict in space. Different cultural perspectives could lead to misunderstandings and conflict. Isolation and communication challenges could create divergent values and conflicting goals. Section 3. Guardians of a New Dawn. Space colonization offers a chance to break free from conflict cycles, fostering peace and cooperation. International agreements and legal frameworks are crucial for peaceful cooperation in space. Education and cultural exchange programs promote understanding and prevent conflict. Embracing cooperation and diplomacy ensures our journey to the stars is peaceful and progressive. Section 4. The Pale Blue Dot Legacy. As we stand on the cusp of becoming a spacefaring civilization, the image of Earth, a fragile oasis of life, reminds us of our interconnectedness and responsibility. The lessons from Earth guide us in space colonization, helping us create a future where humanity thrives among the stars. Environmental challenges on Earth highlight the need for sustainable practices as we venture beyond our planet. Space colonization offers a chance to develop innovative technologies for a sustainable future on Earth. The social and political challenges of space colonization provide an opportunity to rethink our social contract. By prioritizing cooperation and inclusivity, we can create societies that reflect the best aspects of humanity. The search for life beyond Earth reminds us of the preciousness and fragility of life. Discovering extraterrestrial life would profoundly impact our understanding of our place in the universe. As we venture beyond Earth, we carry the legacy of our pale blue dot, a reminder of our interconnectedness and responsibility. The choices we make today will shape the future of humanity among the stars. The question of whether humans can truly live on other planets is no longer science fiction. It demands our attention, ingenuity, and collective wisdom. The journey is fraught with challenges and ethical dilemmas, yet the dream of becoming a multi-planetary species speaks to our yearning to explore. The weight of our choices has never been greater. Our decisions today will determine human destiny. Will we learn from past mistakes or repeat them in space? The allure of space is undeniable, but we must be responsible. The pursuit of knowledge must be tempered with ethical conduct. The choice is not just if we can live on other planets, but if we should. The future hinges on our wisdom and courage. Despite the challenges and the weight of responsibility, the prospect of humans living on other planets fills us with a sense of awe and wonder. It speaks to our innate curiosity, our desire to explore the unknown, and our relentless pursuit of knowledge. The universe, with its billions of galaxies, each containing billions of stars, many orbited by planets of their own, offers a canvas of unimaginable scale for human ambition and imagination. The possibilities, once we unlock the secrets of space travel, of harnessing the power of the stars themselves, are as limitless as the universe itself. Imagine a future where human settlements dot the solar system, where research outposts on Mars unlock the secrets of the red planet's past, where underwater cities on Europa explore the depths of its hidden ocean, and where asteroid miners harvest resources from the solar system's vast storehouse of raw materials. Imagine a future where humans, adapted to the challenges of their new environments, develop unique cultures and societies, enriching the tapestry of human civilization with their diverse perspectives and experiences. Imagine a future where contact with extraterrestrial life, perhaps even intelligent life, reshapes our understanding of our place in the universe, challenging our assumptions and expanding our consciousness. The discovery that we are not alone in this vast cosmos would be a transformative event, forcing us to confront profound questions about the nature of life, intelligence, and our responsibility to other sentient beings. The pursuit of a future among the stars is not just about escaping the problems of Earth, but about embracing the potential for growth, discovery, and the evolution of our species. The story of humanity's future in space is yet to be written. It will be shaped by our choices, challenges, and discoveries, a story of triumph, tragedy, and human resilience. The path ahead will not be easy, but we will reach for the stars, driven by adventure and curiosity. The universe is vast, filled with wonders yet to be discovered. The story of humanity's future in space has only just begun. The time for timid steps is over. We stand at the edge of a new frontier, a frontier that beckons us to explore, to discover, and to push the boundaries of human potential. The journey ahead will demand courage, not just the physical courage of astronauts strapping themselves into rockets, but the moral courage to confront our own biases, the intellectual courage to embrace new ideas, and the collective courage to work together towards a common goal. We must embrace the unknown, not with reckless abandon, but with a healthy respect for the challenges that lie ahead and a deep commitment to ethical conduct. We must learn from the mistakes of our past, from the conflicts, the inequalities, and the environmental degradation that have marked our history on Earth. We must strive to create a future among the stars that reflects the best of humanity, a future where cooperation, sustainability, and the pursuit of knowledge are paramount. The journey to the stars will not be easy, but it will be worth it. For in reaching for the stars, we are not just exploring the universe around us, but also the boundless potential that lies within each and every one of us. It is a journey that will challenge us, inspire us, and ultimately redefine what it means to be human. Let us therefore embark on this grand adventure with open hearts, open minds, and an unwavering belief in the power of the human spirit to achieve the impossible. Let us write a new chapter in human history, a chapter that begins with a single step, a single dream, and the courage to reach for the stars. The time for timid steps is over. We stand at the edge of a new frontier, a frontier that beckons us to explore. The journey ahead will demand courage, not just physical, but moral and intellectual. We must embrace the unknown with respect for the challenges ahead. Let us write a new chapter in human history, a chapter that begins with a single step, a single dream, and the courage to reach for the stars.